Hey, hello everyone, and thank you for joining our routine meeting of KubeEdge SIG AI. Let me share the screen. Okay, um, here is Mu Zheng, the rotating host of June and July. Uh, we see couple of new faces on the KubeEdge SIG AI meeting. So let us give a brief overview of our KubeEdge SIG AI. It is a special interest group that focuses on how is collaborative AI, which is a new paradigm of AI development and deployment that leverage the resources and capability of both cloud nodes. Our mission is to explore the advanced architecture design, technical implementation, and standardized solution of cloud-edge collaborative AI. And we currently have two subprojects under this group. The first one is Sedna. Sedna, in fact, is a cloud-edge collaborative AI framework based on KubeEdge. It enables the developers to implement various collaborative training and inference functions across current age, such as joint inference, incremental learning, federated learning, and lifelong learning, etc. It also trying to support the seamless migration of existing AI applications to like reduce costs, improve model performance, and protect data privacy. We also have Janus. Most of her members working on Janus. It is a Clarity AI benchmarking suite. In Janus, we provide open source dataset, baseline algorithm, test metrics, and standalone test capability for collective AI algorithms. It helps our algorithm developers to quickly evaluate and compare the performance of different algorithms, then promote more efficient and effective development. In today's meeting, we will discuss the progress and challenges of the two sub-projects, as well as some future plans and opportunities. So in this afternoon, we have like uh, three topics to discuss. Two is in the intellectual session, in which we will speaking in English manner. First is the talk rehearsal on KubeCon India 2026 from presented by Ronak. We also have a proposal review working on Janus Sandbox engineering, engine for the parallel processing and other discussion. And finally, we will have a keynote meeting in the Chinese session, which will speaking in Mandarin Chinese, talking about the future program of the LMS Mentorship 2026 Term 2. So this is basically the meeting schedule today. Hopefully all of us could found this meeting informative and productive. Okay, so let's get started. Um, then let's welcome Ronak to present the KubeCon India talk. Hello, Ronak.
Hello, sir. Am I audible?
Yes, please go
Okay,
ahead.
so
Yep.
yeah, so I'm sharing my screen. My screen is visible.
Yes,
Audio is audible.
yes.
Okay, so this is like a rehearsal for the KubeCon India talk, which is going to take place on 18th and 19th of June, the upcoming week. So I'll be saying or I'll be presenting as if I'm presenting itself in India, Mumbai. So let me begin with it. Hello everyone. Welcome to KubeCon Cloud Native Con India 2026. Here is the incredible city of Mumbai. You know, I've been to a few tech conferences before, but there is something absolutely different about being here, talking about cloud native technologies in front of the community. This hits different because this week is all cloud native. So let me ask you something before we begin. How many of you here today manage infrastructure that lives outside a data center? Maybe on a factory floor, maybe on a vehicle, maybe on a device sitting in a field somewhere, or mounted on a wall in your house. Show of your hands. And that's exactly why we are here today. Because here's the thing. We all know Kubernetes is phenomenal. We all know that it has transformed how we think about deploying and managing applications. But Kubernetes was designed for the cloud, for data centers, for environment where you have stable network, reliable power, and plenty to compute. But what happens when your workload is running on Raspberry Pi in a remote warehouse? What happens when your device is a CCTV camera in a village where the internet goes down every evening? What happens when your compute node is literally orbiting the Earth? And that's, my friend, where is KubeEdge comes in. Today, I'm going to talk about a deep dive, not just into what KubeEdge is, but why it is matters. Especially for a country like India, we are going to talk about real world scenarios. We are going to talk about intelligent surveillance, smart agriculture, cloud native robotics. We are going to explore the architecture. We are going to look at edge AI, benchmarking, embodied intelligence, and robotic orchestration. So let's start with it. Uh, First of all, I would like to thank everybody who was involved in this. My name is Ronak Raj. I am an AI researcher working with LFX at CNCF CubeEdge. And I have to say that I'm incredibly honored to be standing here at KubeCon India representing my project that has genuinely changed the way I think about infrastructure and AI. I would like to give special thanks to Ms. Yu Bao, the KubeEdge maintainer, Dr. Zimu Zheng, and Dr. Sizing Hu, who supported me to come up to this milestone. And I'm proud to be the contributor of KubeEdge. All right, let's start with a very basic question. What is KubeEdge? Let me give a very small version of it. We will unpack it slowly. KubeEdge is the world's first cloud native edge computing open source project, and it is designed for one specific, powerful purpose: bringing the full power of Kubernetes to edge devices with seamless cloud edge collaboration. Now, what does that mean? Look at the architecture diagram. We have the full working of KubeEdge right on the screen. We have Cloud Core. Cloud Core sitting on your cloud backed by Kubernetes. It has a cloud hub for communication, a device controller, and an edge controller. This is your brain, the command center. On the left side, we can see Edge Core, the lightweight runtime that runs on the edge device. It contains components like Edge, Meta Manager, Event Bus, Device, Twin, Edge Hub, which are the muscles of KubeEdge. Out of there in the field doing the actual work. The two communication over a web socket tunnel, and this is where the magic happens. Now here's what makes KubeEdge remarkable. This isn't a Kubernetes wrapper for edge. It's a complete rethinking of how cloud native principles apply when your network is unreliable, your compute is reconstrained, and your devices are diverse. Look at the left side of the slide. The use cases are already breathtaking. Flexible quality inspection, OCR, facial recognition, behavior analysis, device management across solar panels, wind turbines, autonomous vehicles, x86, NVIDIA GPUs, from Docker containers to Zigbee and Bluetooth. KubeEdge can be used at every place. Now it does all of this under an open governance model as a part of cloud native computing foundation. This happens no vendor lock-in, no proprietary black box, no community driven test open source infrastructure. This is what Kubernetes meets edge computing looks like. So let's talk what is the complete path and journey of KubeEdge. One thing I want to highlight before we go further, in 2024, KubeEdge achieved CNCF graduation, which is the highest maturity level a project can reach in the cloud native computing foundation. This is huge. This means the project has demonstrated production readiness, governance maturity, security standards, community health, and real world adoption at scale. To put that in context, projects like Kubernetes, Prometheus, Envoy, these are CNCF graduated projects, and KubeEdge is now one of the league. We need to know what makes KubeEdge to the level of graduation. Let me walk you through three core pillars that makes KubeEdge earn this distinction. The first point is the Kubernetes compatibility. The Kubernetes compatibility. We already know what Kubernetes is. I'm guessing most of you already know. If we know what is Kubernetes, we already know how to use KubeEdge because we use the same kubectl commands, the same YML manifest, the same deployment objects, the same config maps, and the same daemon sets. So if somebody is knowing how to use Kubernetes, the person already knows how to use KubeEdge to some extent. The second point is autonomous edge computing. This is where KubeEdge goes beyond what vanilla Kubernetes can do. In the traditional Kubernetes setup, if your node loses connectivity to the control plane, things go sideways. The pods start failing, scheduling breaks. But with KubeEdge, edge nodes are designed to operate autonomously. The edge core runtime catches pod specification and metadata locally. Application keep running, devices keep functioning, and when the connectivity is restored, everything syncs automatically with the cloud. And this is the feature that everybody is talking about. Offline resilience isn't nice to have in edge computing. It's a requirement. And Kubernetes treats it as a first class citizen. The third most important point is cloud edge device integration. KubeEdge doesn't just manage compute workloads, it manages physical devices too. Through its device twin and mapper framework, KubeEdge can connect, monitor, and control IoT devices using industry protocols like Modbus, OPC UA, Bluetooth, Zigbee, all through a unified Kubernetes native API. Like the cameras, the sensors, your actual actuators, these are all become first class citizens of your cloud native platform. We get infrastructure, we get applications, devices, one unified platform, and this is KubeEdge. Let's talk about something which is a little personal to me. We can talk about architecture diagrams all day, but the most powerful way to understand why KubeEdge matters is to look at real world problems. Problems that real people face every single day and to see how KubeEdge solves them. Since we are here in India, at KubeCon India, I want to ground everything I am about to say in the Indian context. Because India is not a single environment. India is huge. India is 1,000 environments. We have tier one cities with blazing fast 5G. We have remote villages where power cuts are a daily reality. We have high tech manufacturing plants and we have farms that stretch across horizons. In this spectrum, KubeEdge is designed for both. So today, I am going to cover three real world cases that I have personally encountered either in my own life or my research work. The first one is intelligent surveillance. Real time video analytics, or what we call as CCTV cameras. This is the first scenario. Second scenario is smart agriculture. The edge intelligence in precision farming like harvesters, microprocessors, sensors, farming, etc. And the third one is smart robotics. That is cloud native robotics at a scale. So let's talk about each one of them. Let's know the story and my own experience regarding each one of them. Okay, story time. About so about a year ago, I installed four CCTV cameras at my house, And I was genuinely excited. Finally, some security, but very quickly, I ran into three big problems that frustrated me very deeply. The problem one was no intelligence. The cameras just record. They can't track a moving object. They can't detect unusual activities. They cannot give us an alert when something suspicious is happening. They are just dumb boxes which are fixed on the walls. First problem. The second problem was the Wi Fi dependency. The cameras are installed in a semi remote area. Okay. So the power cut was a common issue there. When the power goes, the Wi-Fi goes, and when the Wi-Fi goes, there is no footage. I checked my recordings one morning, and after the outage, there was a complete blackout. So hours of unmonitored time, everything's gone. Okay, this was the second issue. The third problem was the storage cost. The camera's system gave me a weak local SD card storage, which gets overwritten automatically. Okay. What was required was a cloud backup. But for that purpose, there was something called subscription. I had to subscribe, pay monthly to get the cloud recording feature, which was again a big issue. Now, these many issues were just in front of me, and I was thinking like there was no solution. This is one case. Another case that I witnessed recently was in my recent scene, I gave an interview for a German based world class manufacturer who manufactures agriculture machineries. And the problem they were facing was they wanted agriculture 4.0. Agriculture 4.0 means adding predictive sensors, IoT devices, smart machines, AI models in agriculture. But at the same time, the problem was very big AI models which uses PyTorch, TensorFlow, etc. And their deployment and their expense. It was very expensive to deploy them to a very small size because they had to be installed in a microprocessors. That was another problem. These many issues I faced in a in a couple of months back. So I was thinking there is just one solution, KubeEdge. KubeEdge can deal with each of the issue on its own because KubeEdge gives us edge autonomy, it gives us lightweight AI deployment, and at the same time, open data ownership. KubeEdge is open source and free. Anybody can use it. Just know how to use it. So second thing, it can deploy big AI models into very lightweight stuff. Third thing, of course, it has the connection with Kubernetes, something which is trusted worldwide. KubeEdge was a solution to it. But there was again a question in my mind that how is this going to happen? Is this so simple? No. Let's understand it one by one. Looking at the architecture of how everything works. The first question was the Wi-Fi blind spot. This is a very big problem because not you might be asking how does KubeEdge actually keep things running, but the network drops? Because the problem was when the internet connection or the Wi-Fi was available, there was a footage available, but when the Wi-Fi was gone, the footage was gone. How KubeEdge deals with such big issues? See, how this happens, we will understand it with this architecture diagram. On the cloud side, we see cloud core. On the edge side, we see there is a edge core. Cloud core contains the cloud hub, okay, which communicates with the Kubernetes API server. Cloud hub remains the WebSocket tunnel to edge nodes and sends state bidirectionally. On the other side, edge core is available. This is a lightweight runtime that does the heavy lifting. Let us talk about each of them. We have edge hub. Edge hub is the communication gateway. We have Meta Manager. Meta Manager is the brain of the offline resilience. It stores the pod specs, uh, config data, metadata to the local edge store, a persistence on device database. Uh, the edged we see here, the edged is a lightweight kubelet. And finally, we have device twin. Device twin maintains a digital representation of physical IoT devices, sensing desired state from the cloud with actual device state at the edge. See, these are some powerful recent features updates too. Support from image pre-pull on edge nodes, auto restarting of edge modules, and more deployment field overrides for edge applications. This was one scenario. Another thing was how to turn the dumb cameras into smart cameras. Okay, okay. So we know why we need intelligent cameras. We know that now because in the time of AI, we want the best features to be available in all the devices. Now we know the architecture that makes offline resilience possible. Now let us talk about the exact mechanism that can turn those traditional cameras into smart cloud native IoT devices. The main feature here we are going to understand is the DMI and the edge mesh. DMI, the device management interface, it is the KubeEdge's next generation standard for IoT device management, and its fundamental device it decouples the control plane from the plane for IoT devices. Second is the edge mesh. Edge mesh is again a very powerful distributed networking solution for edge environment. It provides the DNS resolution, load the balancing, traffic proxying, peer-to-peer tunneling, all without requiring a stable connection to the cloud. These two layers does the actual device communication. We have the matter in the in between. We have the mapper communication. We have the mapper container. The mapper container, okay, does the actual device communication. It has pluggable control plugins, OPC, UA, Modbus, Bluetooth. For whatever protocol your cameras or sensors speak, it handles data collection and forwarding independently for the control logic. So what is the result? My camera is no longer just record it is my sorry. My camera is no longer just a recording device. It is managed, observed, AI capable service in your cloud native platform. Developers focus on their applications, but KubeEdge handles the infrastructure cleanly, elegantly, and powerfully. This is just not the end. We just covered three scenarios, but that is just the beginning. We have to understand KubeEdge has come to this point going through a huge milestone. The timeline of KubeEdge started in 2018 September when KubeEdge was launched as an open source project. In November 2018, it entered the CNCF sandbox. In 2019, the first version of KubeEdge was released, and 2019 June, 1 lakh edge servers production took place. Similarly, 2020 September, CNCF QEdge became an incubating project, followed by its graduation in 2024. This looks like easy, but if we look what is really a benchmark, in 2021 was a landmark year. KubeEdge gained native Kubernetes API support at the edge. The Sedna sub-project launched for AI collaboration. Edge Mesh became an official sub-project. And at the same time, this was is genuinely amazing to me. The first cloud native satellite was based on KubeEdge, was launched into the orbits. That was 2021. It means that KubeEdge is growing every year. In 2023, the first CNCF project to achieve SLSA level by launching a Cube Robo, focusing on robotic solution. KubeEdge releases the story. The release tells the history, same story of rentless problems. That's not the end. After the graduation of the project, KubeEdge gone through many releases. Releases of the January 2024 when the patch Edge Node remote upgrades took place into the release of version 1.19, the Edge event reporting to the cloud and a fully revamped dashboard. Each release isn't just a release version, it's a statement. Cubase ships production grade features consistently, predictably, and growing community behind every line of code. This is truly incredible to see a CNCF project growing so rapidly and covering the milestones every year. Now, we have seen the infrastructure, we have seen architectures. Now, let us talk about the most exciting layer at the top of all this, the edge AI. Because deploying containers at the edge is powerful, we know that. But deploying intelligence at the edge is questionable. That's transformative, right? KubeEdge has two dedicated sub-projects that makes it possible. The first one is Sedna. The second one is Yanvis. The first one is a AI the first one, Sedna, is a AI framework, and the second one is a AI benchmarking engine. Together, they completely form an AI edge ecosystem. Let's meet them one by one. We will talk about KubeEdge's Sedna first. Sedna is a KubeEdge distributed AI framework built specifically for edge cloud synergy. Here's the core idea. In traditional AI, you train in the cloud, you deploy everywhere, right? But what if your data is at the edge and can't move to the cloud? What if your model needs to adapt in real time based on local conditions? And this is where we use Sedna. Okay. Sedna supports four powerful learning paradigms. First one is joint inference. Second one is incremental learning. We support Sedna supports federated learning, lifelong learning, and many more. The architecture is clean. We see there is a global manager. Global manager on the cloud handles the task coordination, the model, the dataset management. There is a local controller. Local controller on the edge handles the actual training and inference works. Communication happens on the KubeEdge's messaging layer. Look at this. Sedna is a framework agogistic. That means TensorFlow, PyTorch, Paddle, Mind, all these are supported. All AI models are supported by Sedna. Plug in your algorithm, define your task. Sedna handles the distributed orchestration very well. Let's talk about the another repository, KubeEdge's Yanvas. Now, how do you know your AI model, your edge AI model is actually good? How do you compare algorithms fairly? How do you benchmark distributed AI in a standardized way? Now, this is the job of Yanvas, KubeEdge's AI benchmarking framework. Yanvas is a modular by design. It has three core layers, as you can see in the architecture. The first layer is the test environment manager, which manages the data sets and the matrices. The second layer is the test case controller, which runs your algorithm against defined learning paradigms like single learning, incremental learning, lifelong learning, right? It also includes a generation assistant and a simulation controller for advanced scenarios. Third one is the story manager. Manager is responsible for generating the leaderboards, the test reports, gives us reproducible, comparable results across the algorithms and teams. Now, Canvas support the same learning paradigms as said now, joint, federated, incremental, lifelong, and is compatible with the mainstream AI framework. The goal is simple. We want standardize how we evaluate AI at the edge so the community can build on shared, trustworthy benchmarks. This is not just the end because Yanvas is growing rapidly. Let's talk about the example directory. Let me show you how rich Yanvas example ecosystem already is. The example directory is organized into five categories, and each category has several examples with datasets, algorithms, matrices defined, each of them workable. The single task example category already covers a lot of different tasks under computer vision, LLM and language tasks, robotics, embodied intelligence, specialized domain tasks like government talk to poster AOA. In the lifelong learning, we get to see examples like LLM language task, document parsing, LLM edge benchmark. Similarly, federated gives us the data sets for CVAR, algorithms for CIFAR, PIPL, federated LLM, and cloud edge collaborative edge multi-edge inference. Similarly, has examples and data sets, algorithms for MOT17, cloud edge LLM, cloud edge spec decoding. Each of them, critically, each of them has great use and is used by many people, researchers, developers in their research work, education, and learning. And critically, active LFX mentorship work is restoring and expanding these work, adding CI/CD pipelines, modernizing documents, building automation validation infrastructure, restoring the broken examples, locating the data sets to the correct paths, etc. This ecosystem is very much alive and growing. Out of all the examples, I will I will myself like to focus on few of them specially. But before that, let's really learn and understand the Yanvas release roadmap, which shows us the project that started focused and is expanding ambitiously. Okay, so we have three successful releases of Yanvas: version 1, version 2, and version 3. First version established the core framework of benchmarking, test environments, gate management, leaderboard, test reports. The second version introduce the full lifelong learning support, the complete task lifelong management, unknown task recognition, matrices, result visualization, cloud robotics, data sets, etc. And the third version worked on cloud edge collaborative, speculative decoding using Eagle, pedestrian tracking, etc. Out of all the releases, there are two deserve special attention here. The first one is embodied intelligence. Yanvas now benchmarks physical robotic tasks. The deformable component assembly, which I have personally contributed to, uses YOLO V8, Force Dark sensor, and cloud robotics. The whole market today of embodied intelligence is of $2 trillion. Physical AI market in the opportunity. Yanvas is building the benchmarking infrastructure to help the community capture its responsibility. Okay, let's talk about something that genuinely excites me, my work and certain work of Yanvas, which is truly appreciable. We have RoboDK palletizing, which is like industrial robots picking and placing object in warehouse scenarios. This uses YOLO V8 for detection, GraphNet for grasping, Kalman filtering for denoising. MAP50 and MAP90 are used for precision matrices, a great contribution to Yanvas. Similarly, LIDAR inertia pose estimation, great contribution, uses the Kitty dataset for dataset training, Li- LIDAR inertial LIDAR autometry for the algorithm, benchmark project, which is available of Yanvas, used immersely for research purpose, for study and by developers and users. Third one, deformable assembly. Actually, this one is mine. I contributed this benchmark to Yanvas. A robotic arm assembles deformable electronic components, a kind of flexible, irregular parts that are notoriously difficult for robots to handle. We use YOLO V8 for visual detection and force torque sensors for visual feedback. uh, I would like to show up a video that describes how we can use the data set properly for our research work using Yanvas. Presenting the video, I hope this is gonna be liked by everybody. Let's give our 5 minutes to see this video. By understanding audit intelligence, real intelligence comes not Well, the video which you just saw, this is just not a demo. This is a reproducible benchmark. Anyone in the community can run this, evaluate their algorithm against it, and compare the results on the Canvas leaderboard. Project that can truly be used for research develop by developers, researchers, students for their studies and benchmarking. That's the power of open benchmarking. You just don't build the robot, you prove the robot works consistently, transparently at the edge. Now, this does not just stop here because now we already have the data sets, we have the benchmark, we have the train models. Everything is available to Yanvas. The next question is, how do you deploy them? How do you orchestrate the robots at this scale? This slide answers this very beautifully. The architecture is a three-tier cloud handles, three-tier. Firstly, it explains how cloud handles the high-level reasoning task. This is powered by LLMs and near natural language task understanding. The warehouse edge nodes handles flow prediction, task assignment, and routing plan for robot fleets. Robots at the edge are heterogeneous, different manufacturers, different form factors, all connected through KubeEdge's unified device management. Think about this, which enables an operator which types a natural language instruction like send a panda to port B, and the system understands, plans, and executes autonomously across a fleet of robots. No manual programming per robot, no proprietary middleware, just Kubernetes native orchestration extended to physical machines. The results speak it themselves. End to end deployment cycle has been reduced by 30%. Robot management efficiency is improved by 20%. Integration time for new robots cut from months to days. That is called true development. This is called true dealing with the challenge. The challenges are real. Natural language comprehensive for robots, cognitive management at scales, heterogeneous device integration, but KubeEdge is actively solving all three. This is cloud native robotics, and it's happening now. This is not just what it seems, because step back and if you look at the bigger picture, from 2018, a CNCF launch project, to 2021, getting the sandbox project credibility, to 2024 becoming KubeEdge, the CNCF graduated program. It's just not so easy. KubeEdge has actively participated in LFX and OSPP mentorship programs for produced a steady team of contributors tackling real problems. AI PCs and managed edge nodes, alternatives to API-table managers, cloud robotics benchmarking, RISCV support, edge native LLM inference, and that's not the end. Every term, every new project, each time a new contributor, and every time there is a huge contribution to KubeEdge. These aren't toy projects anymore. These are production grade contributions. KubeEdge is no longer just an edge infrastructure project. It is a connective tissue between the physical world and the cloud native ecosystem. We can see it in real world. Let's look at the diverse partners of KubeEdge. KubeEdge doesn't operate in isolation. Look at the slide from ARM, Samsung, Hawaii, China Mobile, China Telecom, China Unicom, Orange to the academic side, from Fudan University to Hong Kong Polytechnic. CubeEdge's infrastructure is every time top. This breadth matters. It means KubeEdge is being stress tested across industries, telecom energy, logistics, manufacturing, and agriculture, automotive. It means architecture, which we just read. It means the architectures which we saw. Everything is working in production at a massive scale. And it means the community will keep growing. When a CNCF graduated project has this kind of cross industry, cross academia adoption, you know it's just not the trend. This is the infrastructure. At last, we started our story about four CCTV cameras in a remote area that stopped recording. When the Wi Fi went down, we traveled from edge architectures, AI framework, robotic benchmark, warehouse automation. We went from a simple problem, why is my camera footage missing, to the realization that the same technology solving the problem is also orchestrating robots in industries, in warehouses, enabling autonomous vehicles and running workloads in orbits. This is KubeEdge. It's not just about edge computing, it's about extending cloud native principles, reliability, scalability, observability. to every corner of the physical world. And for a country like India, with the incredible diversity in environments, industries, challenges, this technology has enormous potential. To the whole community, KubeEdge community, the CNCF mentors, thank you for being and building something that we're talking about. That's it. Thank you. Thank you, everyone.
Okay, very cool, very comprehensive um presentation, and thank you so much again, Ronak. It looks perfect. It looks perfect. Um, as we have discussed the whole storyline, right? So this follows the storyline we have discussed from the whole KubeEdge, and then get into like KubeEdge signal, KubeEdge like SIG networking, and then come to KubeEdge SIG AI. We discussed the video project, the robotic project, um, and the future roadmap. So the whole storyline yeah, makes many sense to us. So I think the whole committee will be very appreciative for the whole presentation, and looking forward to like um, the on-site presentation in QCon India. That's a little bit comment on this. The whole presentation looks perfect. But that's just the presented video, the first presented video. Like the audio track looks like not super clear to online audience. So I think that could also happen for next week, like the KubeCon India 2026 try to record the video and replay on like YouTube, then the audio track could be broken a little bit after uh, different times of round uh, recording. Then I think Lonak may consider having some captions in the video, or maybe you can, when playing the video, you can use some like um uh live on-site video expansion on the conference. So using the mic to expand the video a little bit, that could help when KubeCon India try to record the whole uh speak. So making the video presentation more vivid. So this is just a tiny suggestion. So, but the overall speak looks perfect to me. So we typically maybe we have like 30 or 40 minutes for this talk, right?
Yes, sir. Sir, come
Yes.
again. The last sentence.
Sorry. We how long is the time slot for our speak? So maybe like
Yeah,
we have 40 minutes.
I have 30 minutes. Did I exceed it?
Yeah, I think it's
Okay.
like 5 to 6 months. So maybe mm, I think we can like shorten the background on the very beginning. Like um let us focus on the AI issue. Um maybe we can have
Like,
briefer, yeah, like yeah, on signal and the Wi-Fi thing. So that could help. You can try to use a time limiter to try to at least try to limit control the whole length of the speech. But it's fine. I think it's fine. Um, uh, but the video issue, I think you can consider it a little bit. We still have about 1 week, right? So I think you can prepare a little bit for the video um, captioning. So or you can have a like on site video explanation on the conference. What do you think?
okay, sir. Okay, thank you. Thank you so much, sir. I will consider to all the comments. Firstly, yeah, this could be a concern if the audio is cracking to the online audience. It may also it may also crack at that presentation. So I'll be adding the captions as well, and I'll be even using the mic in the conference to describe the video from the back. I'll mute the voice of the video, and I'll use my original voice at the spot to describe the video. Maybe that is going to be better, more interactive, and yeah, I will shorten the explanation, make it more comprehensive at this side. Edge and Wi-Fi part, the cameras part, I'll make it a little more comprehensive so that the speech is concluded within a time span of 30 minutes.
Okay, cool. So I think then it looks perfect. Yeah, then
Yes,
maybe
sir.
yeah. I think we will have a very excellent speak on that meeting. I'm looking forward to that.
Yeah, yes, sir.
Okay, and are there any comments from our online members? Dr. Sitting, do you have any uh what do you think? What do you think of this presentation?
Hi.
Maybe
I
yeah.
think I also think it's a good presentation. Yeah, very impressive. Yeah, I don't have any other comment.
Hey,
Thank you.
so
Thank you,
yeah,
sir. Thank you.
yeah, we will be very appreciated. Yeah, yeah, and best wishes, and I think we will have a very good um impressive talk on the Kubicon India and a tiny shot for our audience. um, very good presentation. And I would like to say Lord Mark again for the wonderful presentation, and that's take consideration of our previous comments. I think everything will was fine on the Kubicon India 2026.
Yes, sir. Yes, sir. Thank you. Thank you for again giving the opportunity for the rehearsal. This is the second time I'm doing the rehearsal, and you again giving the comments, great comments to improve the slides and everything. Thank you, sir. Thank you.
You're welcome. Okay. So I think that is the first agenda topic, and help us learn more about the whole QS AI, QS SIG AI progresses. Thank you, Laura, again. And then we come to our second agenda topic from Pragnia, right? For the YANO sandbox engineer and engine for the parallel processing. Pragnia, are you
Yeah,
online?
yeah, Zimu. Thank you. Thank you very much for the opportunity here in this meet so that I can propose the idea as well as I have some few PRs as well open for this particular proposal. Basically, it is all connected. So thank you all for having this time in this meet. So let me just share the screen first. Let me know if this is visible or not.
Yes, please go ahead.
Yeah. Is it visible?
Not yet. Wait a minute. Yeah, now it's visible and you are audible. Please
Okay,
go
okay.
ahead. Yeah.
Thank So basically, over the last 3 weeks, I was like completing a stability audit. That is this issue 495. You can have a look over here. So in this, like my goal was to make sure the core framework is highly stable before we scale to distributed parallel benchmarking. Now, the last 2 weeks were like fixing the issues, the major issues that were like the framework core hardening, like the metric division zero guard, like all these are like minor issues. Path portability, like we have to replace the hard coded paths and some NAN sanitizations as well. And then a few two example restoration that is from the application layer. Now, considering all these PRs and the issues, basically fixing that, it actually led to me a bigger side of a problem. Now, in the last meet, as Zimu also stated about the highly, the priority tasks that we had, that were the parallel processing and other issues that were just there. Like, let me open that as well. Uh, just a second. Yeah, where is it? These. Now over here, I actually looked upon some few issues that were like the BLA data mixture, that is around issue 200, and PIPL privacy, that is issue 203. I also reviewed some past LFX and OSPP contributions, and I noticed a pattern of friction when running new models here. Some issues as well, like over here we have LLM Edge benchmark, that is issue number 94, and government agents. Now, all these issues, what were happening was contributors had to change core Yanvis files just to make their unique models run, and contributors hard coded the absolute file paths because they could not easily manage the local dependencies. So basically, the bottleneck was the modern AI models like LLMs and VLAs require heavy conflicting dependencies. Currently, we force all these different models to run inside the same global canvas environment. This causes a dependency conflicts and path errors. So my solution that I prepared last week, although it is like a first draft only, a much more improvised versions can come later in future time. But over here, what I propose is like we can decouple the model execution from the Canvas core framework by moving to an isolated sandbox execution. All right, so we can solve these dependencies problems permanently. Even the upcoming examples or benchmark, like the algorithms, could be run in that sandbox, and it could easily be like without any changes in the major parallel that core framework and the dependencies. It can easily run on each and isolated environments. So it is like a future prospect. I'm thinking of that way. Now, the technical pillars we have over here, the key technical pillars, we can say environment isolation. First of all, each algorithm runs in its own isolated environment using VENV or a lightweight container. So here's my proposal. Just a second. You can get a better look over there, no? Yeah. So here's my proposal. I actually just opened a PR over here in that same format that Zimu told me in the mail. So second was the automated resource limits. Now the engine will automatically restrict the sandbox resources. This allow us to simulate weak edge devices accurately. Then we can have an opt-in design. The sandbox is backward compatible, like old examples will still run globally that are actually already there, existing ones. All right. So new examples can enable the sandbox using a simple flag, like we can have a benchmarking job.yaml file, and we can just raise a flag over there if we need a new environment or the sandbox processing. So for the new examples to run on. Now for the validation part, if you'll come like here, the validation strategy, we can test this architecture by moving to the MOT 17 and Tiny GPT-2 benchmarks into the new sandbox. Right, for my phase, like for my validation, the work that I will be doing in the LFX term, if they output the exact same results as the global environment, the sandbox is ready for production. Then, according to the proposed roadmaps, my phases like phase one will be merge the current audit cleanup, that is around 496 to 500 PR. This one, we can have a nice decent amount of time here so that we can together fix these, like merge these PRs. They are like I've already, committed and fixed the issues that were raised by the KubeEdge bot. Then we can have the phase two part that where we can build a sandbox manager over here. That is this one. All right. For interfacing for the isolated execution, then we can have phase three using the sandbox to solve issue. That is the main parallel processing issue that you just showed me in the last meet, Zimu. Uh, it was here, I guess. Where is it? This one. So according to this issue, actually I made my whole proposal here. So this is the basic foundation of it. Now isolated environments means we can safely run multiple benchmarks in parallel. Now in previous attempts, like we had Vibor, like yeah, this one. So what he did was like he actually run those parallel threads in the same CPU core. Like we have multiple cores, so in that he actually run those parallel processing. So that was not a good idea because it actually had many cons. All right, so that is why my proposal will be slight different from this one. We can actually create an isolated sandbox engine for each and every uh, examples to run on. Then we can scale the engine to support the new multimodal benchmarking as well in issue 307 over here. And by implementing this sandbox, actually we can like we have so many over here and unimplemented tasks like the single task learning, and so many issues are still raised over here. We can actually solve those issues indirectly or directly by my proposal, like the sandbox engine. Now, for the maintainers, like I would have a slight a questions for them based on the architecture. Now, right now, I am actually thinking of a lightweight or a local, method that is VNV or Docker. So, what you think according to it, like what will more match to the architecture over here? So, I just wanted to ask that, like we need to use the VNV or like we can use Docker or Kubernetes for it. The tooling, I am right now using the UV as the default package manager to make environment creation extremely fast. All right. Now, thirdly, that I have the priorities. Are there specific models you want me to migrate to the sandbox first before testing? So this was my complete proposal basically, and this was my issue, the audit issue. This one. So this is all like connected. So over the past 3 weeks, this was my whole work, the everything that I have done till now. So I would like to have your comments and as well as uh, better improvements. Like where is the scope exactly where I can focus more. So I would like to have those things from you all.
Okay, thank you, Kenya. Um, First, we have Dr. sitting online. So, basically, Kenya is presenting an idea of breaking a new uh, parallel processing idea. Um, it try it trying to build a sandbox to make different parallel processing working on like different container or so-called sandbox. So this is also um, um, previously we have the parallel processing proposals presented by Creation like Beaver, and then we also have something like simulation projects working by working by Yang. So um, I I need some more time to like separate this pull request out. First of all, I would like to ask Dr. Sijing's idea about how you feel about this general direction.
Yes. Uh, okay. Can you hear me?
Yes, yes, you're audible.
Yeah. Okay. I think the direction is good. So we really need to address those issues. But what is in my concern is that the scope of this proposal is a little. I think the scope is too large for this proposal. I mean, if we need to uh, make a sandbox to replace the original engine of Llanos, I think maybe it will have some influence on the existing examples, and so we need to make the change very carefully. So from my point, I think the current proposal, the scope of the current proposal is a little bit too large. So maybe we need to uh I think maybe we need to make the change step by step and to ensure all the changes we make won't have some influence on the existing examples. So that's the main concern. And the overall, I think the direction is a good direction. So the sandbox is a but all we need to make the change more carefully. So since I think it's a big feature compared to the current YAML. Yes. So that's my opinion.
Thank you, Dr. Shi. And any response from Kenya?
Yeah, thank you, Shijing. I completely agree with your concern. We must protect the existing examples and make changes very carefully. So I completely agree on that. To clarify, the sandbox engine will not replace the original engine. It will be strictly an opt-in feature. So like we can have a fallback policy or like the feature in that for running the existing examples as well as the new examples. Now to keep the scope small and safe for this proposal, I will not touch the legacy examples. They will continue to use the original engine exactly as they do today. My scope for this project will only be to build the sandbox infrastructure and apply it to one or two specific examples like the LLM1 or the MOT17 that I've already worked on before in my master issue as well, and opened some PRs on that as a proof of concept that yes, my sandbox infrastructure actually works, like it is, like I've correctly implemented it. If it works well, the community can decide like later if they want to migrate other examples on it or not. So does this smaller or opt-in scope sound safer to you?
Yeah. Uh, that sounds good to me. Yeah. I think you can do the things according to what you all said.
Okay. From my point of view, I agree with Dr. Shi, what Dr. Shi Jing have mentioned. It this one, maybe everybody have noticed that we have already like over 30 examples running with like over 5 algorithm schema. So how would that parallel processing works for different schema in different examples? So this one it needs like comprehensive research on the whole Janus project. Uh, so typically this the feature is very important and very critical, and also a very complicated one. So we also want to thank Kenya for uh, trying to tackle on that, and thank you. And then but also need to be very cautious on the whole design. So um previously when Quiz and and another contributor trying to propose a proposal, we also asked him to like doing some research on how the parallel processing works for different algorithm paradigms. For example, like if we are working on um, federated learning, this one when we do some parallel processing, it will be some kind of easy because federated learning is basically distributed model training, right? So it already works in a distributed manner. So what we done is maybe we create a bunch of sandbox, or maybe we create a whole unified sandboxes with different workers in the uh, in the sandbox, and then um, trying to put the local channel into those workers. Then that works for the uh, federated learning. But for those like lifelong learning, incremental learning, and especially incremental learning that it only have one global model. So how did we do the parallel processing for the incremental learning, especially for the training phases? So this part is we might need more research on that. But generally, the sandbox idea, personally, I also support the sandbox idea. Um, but the sandbox itself also need some more research. In fact, like in um, three 3 years ago, we have another project. Basically, it works for lifelong learning. It creates a container in container techniques, trying to build a simulation sandbox for the whole benchmarking uh, um, benchmarking suite. So you see that in fact, the simulation one is not necessarily connected to the parallel processing, but the simulation one also have different kind of technique, as you mentioned. We might have Dockers, we might have other techniques, and in the simulation proposal proposed like 3 years ago, the final selection in the community is trying to use the current power of Kubernetes. And you know, as we know, Kubernetes already have containers inside, and then KubeEdge itself is an extension of Kubernetes. So we have different containers on the edge supported by KubeEdge, on the cloud supported by Kubernetes. So then I have put the proposal on the chat box, so Peniak may take a look at the design of the simulation system, like 3 years ago. So it basically take good use of the KubeEdge, and what it done, it basically install a KubeEdge in Janus. So by this way, it creates a container and make it more KubeEdge native for the Janus project, and that attracts our reviewers and all our maintainers, because Janus is basically is still a project in KubeEdge SIG AI. So we 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 are very appreciative if we have any idea that trying to connect the main community and our SIG AI. So the proposal by Yang trying to connect the KubeEdge and the Janus, and trying to create the Janus sandbox using KubeEdge Sedna techniques. So that one looks fine to us. So I think Penia can take a consideration of that. But that proposal is also a huge one. So Yang may not finally done that. So we leave it there. But I think the whole sandbox idea is good, especially when in the current state we have like harness engineering for agents, right? So talking about harness, so simulation or the sandbox issue makes more sense in current large language models area. So I think the whole idea is very good, and I think it is the right time that we bring this simulation idea back to KubeEdge SIG AI. So myself, I support the idea, but we indeed need more research for the whole architecture design and the technique selections, and trying to build a good proposal on that. So this would be a very hard work. So we need to bring that out for Penia. That would not be a naive work. It would be a very, very difficult work. So but fortunately, we have some previous proposal for you to take into consideration. So you can take a look at the previous simulation design into your new proposals, and trying to like make the whole blueprint more complete by considering first the simulation design, second the different algorithm, the different parallel processing schemes for different algorithm paradigms. That one is also a very tricky one. So that is my two comments. So considering the sandbox issue itself, and doing research based on the previous Young's proposal, and then also take consideration of the different um, parallel processing scheme for different algorithm paradigms. You can take a look at what Quiz and maybe I can put it in the chat box. We have Quiz proposal and also uh, Viva. I don't know how to pronounce the name, but they proposed the pull request 308 and 419, the two proposals. In fact, in the two proposals, we had some discussion on how to do parallel processing on um, joint inference, lifelong learning, federated learning, etc. So could that could may help you to shorten the length of the whole research. So um, for my point, it is really a complicated project, and I also suggest a comprehensive research to break down the different tasks. First, I think maybe we can separate the simulation feature and the parallel processing feature for different algorithms. Um, we separate this into two features, and then we tackle it one by one. For example, you for to build the simulation sandbox for parallel processing, first we build the simulation, the sandbox techniques for Janus. Then we first do some research on how to build the simulation layer for Janus. Then you take a look at the simulation proposal I have put in chat box. And after we finish the simulation project, then we have the foundation of using those simulation techniques for parallel processing. And then we may need to look at the different algorithm schemes that our 30 examples are now using and make it compatible for existing examples and future examples. So that one is a really large and systematic engineering project. So will be a very large one. I think we can put it in the second step to do. Yeah. What do you think, Ben? Yeah.
Yeah, completely agreeing with you, Simu. Thank you very much for the support and the extremely clear guidance. I completely agree that this is not a naive task. Building a system like this would be a massive architectural challenge, I guess. And I am fully prepared to put in the deep and difficult research required to do it right now. So yeah, I will take this like previous simulation proposal you linked and use it as my foundation. Moving forward, I will focus my efforts on creating a comprehensive, well-researched blueprint. Like, yeah, obviously this was my first draft, so yeah, I was like expecting completely changes for this proposal. So yeah, next time I'll bring out a good one, good proposal, a comprehensive, well-researched blueprint that addresses the two specific pillars, like you mentioned, that was the Kubernetes native simulation design and the paradigm specific parallel schemes. So I
Cool.
will deep dive into that research and will draft a formal detailed design document for that the community to review. Thank you, Zimu and Shijing, for your time and excellent feedback today. This like gives me a perfect clear direction for the proposal. Thank you.
We would like to take this opportunity to thank you too. Yeah, the parallel processing one will be a very important feature, and so is the sandbox feature. So that one is also will be a very important feature because when we have the simulation layer like real containers in Janus, then we can do some like performance managing and monitoring for Janus now. Basically, currently when we do the Janus metrics, we basically monitoring accuracy perspective metrics. So that is because we have the data set, but currently we don't have too much system-wise matches because if we don't deploy in real world or even simulated containers, it is difficult for us to measuring the network performance, the bandwidth, the like computing performance, like the CPU utilization rates, something like that. And if we can build a simulation feature, then you can like fulfilling the another half of the picture of the whole Janus feature. So that one is also very important, right? So I for myself, I very appreciate the idea you raised. So in the next time, I think you can take a very deep research on the sandbox issue itself. That one is already very important, and that could build the foundation for the future parallel processing using sandbox techniques. So you can take the sandbox technique uh, proposal as your consideration first, and next time maybe we can take a look at the sandbox techniques that could possibly use in Janus in a more deep dive manner. So that is what I expected to see in the next proposal review.
Yeah, completely agreeing with you, Zimu. Thank you. Thank you very much for this meet and the opportunity. So likewise, I will bring on a good, better blueprint for the proposal with a more comprehensive and a detailed research. So likely, as it was my first week only, I'll try to give on a better output in the next week.
Okay. Yeah, cool. When it is not necessarily next week. We really need very deep dive research. So it's fine for you. When you get ready for another review, you just send email to me, like you done a few days ago. Yeah. So get some research into it. Then when you're ready, you email me. And we will arrange another agenda to topic to discuss the whole issue.
Thank you, thank you. Yeah, I'll definitely get back to you on this issue and definitely like reach out to you on mail. Thank you, Zimu, and other maintainers and reviewers over here.
Okay. Thank you too, Penya. Thank you for the presentation. Yeah.
Yeah, have a nice day. Goodbye.
Have a nice. See you. Okay. So I think yeah, we like to thank Penya again for the courage to try for the hard work doing the whole proposal research on the parallel sandbox issue. Very good idea and also very challenging one. So we might need more discussion on the proposal itself. It needs very careful design. It is a major changes, not both for the sandbox issue or the parallel processing issue. Both one would be um, typically very important features in the core code of not only examples in the core code of the Janus. We would like a very to see a very deep research on that pull request. Okay. Um. Okay. So I think that is all for the international session. Are there any issues that we would like to discuss in the international session? If not, we are moving to the Chinese session. Since not all of us can speak English very fluently, so we in Chinese session we will try to use Mandarin Chinese, and we will try to keep the materials in English uh, on the screen so that so you guys can still if for international members you can still stay, but we are speaking using Mandarin Chinese. Okay, so that is the end for the international session, and thank you all of our international friends to come again. And if we have any other issue to discuss, we'll come back next week the same time. Okay, so that is the end for the international session. Then we start the Chinese session. OK，那我们就切到中文啊，就来到那个中文的环节。然后今天是比较特别，今天我们有那个新的 那个 mentorship program Term 2的 project 的启动仪式啊，就我们的开工会啊，然后我们也有新的成员像凯威啊，还有其他的那个member 可能会未来也会加入到我们这个大家庭里面来啊，就很欢迎大家。然后呢，时间关系对吧？然后我们会跳掉那个之前一般中国环节会有的那个一些调研啊，还有那个近况介绍，然后我们今天直接进到开工会的环节，分享一下屏幕。大家能看到我屏幕吗？
能看到。
好的，好，然后那今天我们就开始我们这个开会，然后在那之前，反正也做自己的介绍啊，那我现在是那个就现在 SIG AI 的 co-chair，然后当时的那个联合创始人，然后现在是 KubeEdge Janus 的 maintainer，然后呢目前我是在华为这边工作，然后呢是担任那个主任工程师，也是当时大概19年的时候，我在那个港理工这边毕业，然后毕业的方向是那个分布式人工智能，然后后来呢就啊、就加入到华为之后，在24年的时候，然后就一边在华为工作，然后我也当时担任那个哈工大的企业博导，然后帮他们指导他们团队里面的博士生，然后后来也获得了 AI 领域的那个副高的职称，对，那个基本上就在企业这边其实是副教授级别的那个社会职称，在中国大陆这边啊。然后呢，我们近期的工作就主要还是一些人工智能的云服务，然后包括刚才提到的像是那个Sedna、Janus 就都是相关的那个边缘云计算的那个云服务。然后呢，我们现在商用的项目也超过10个，然后也有中间我们也会去发一些像是专利啊，就这些还有对应的一些认可，就在企业这边。然后呢，学术方面呢，就现在发的，我一般会是在就 AI 分布式 AI 领域这边去发的国际的呃比较旗舰的一些会议或者期刊那包括像是 EJCA TPAMI TPDS 这一类在中国这边 CCF 都基本上是 A 类的。然后呢，我们也拿到过2、3次那个 Best Paper，那当然那个公司自己的一些技术突破奖项都很多了，就不用提。然后呢，目前我也是那个 EJCA 还有那个IEEE IoTJ 这些顶会顶刊的区域主席和评审。然后最近我们刚刚注册作为那个国际标准化组织 ISO/IEC JTC SC42就人工智能领域的那个标准化组织的中国代表团专家所以也会去做那个一些国际上面的人工智能的标准。然后现在我们在牵头的那个人工智能相关的一些国家标准已经超过20个了，然后也会去做对应的那个人工智能的评测，这也是为什么我们比较关注 Janus 这个项目就对于评测这块其实还是有很多的工作可以做。然后呢，我们之前出了一版那个分布式人工智能的高校教材，人民邮电出版社的，然后现在在像中科大等等高校正在使用当中，然后我们上周刚跟中科大这边谭老师在谈，我们可能很快也会再版，因为那个大模型这些领域进来之后，那个边缘 AI 这个领域可能也有很大的变化，对，到时候我们可能也会再去做第2版的修订这是我这边的一个基本情况。然后KubeEdge 因为我们有新成员对吧？我们刚刚那个 Ronak 其实已经介绍过了。然后呢KubeEdge 社区本身跟LF 的 Mentorship 其实结合也很紧密。就我们从大概19年开始，然后 KubeEdge 社区其实已经是第7年去参加那个 Linux Foundation 的这个 Mentorship Project 了。然后我们在上面的毕业的项目大概已经有超过20个。然后呢，KubeEdge 本身是干嘛的呢？KubeEdge 其实本身是个云原生的边缘计算框架，就可能大家会知道 Docker 就是谷歌的那些容器，然后后面呢，他们大概在10年前 然后开了一个新的那个项目叫 KubeNet 我们中国这边会叫 K8S，因为它中间 K 和 S 中间有8个字母，然后叫 K8S 然后这个东西其实是就把所有东西都作为容器去做统一调度。然后这个项目其实在基本上所有的那个云厂商里面都是在使用的啊很多的那个你们知道的一些大的投厂商，他们其实内部都是集成的这一类的那个虚拟化的能力这是一个 Docker 的进化版本。然后呢，K8其实变本质上已经是个事实标准了。然后呢，我们的这个项目其实是 KubeEdge 的项目，其实是因为 K8之前是只能用在云上面的，然后在一些边缘设备上，比方说我用树莓派，对吧？我用一些嵌入式设备，然后这时候它底下五花八门没有办法做虚拟化，然后相当于我们把 K8的能力下沉到边缘上面去，然后使得边上面的这些设备也可以被容器统一调度。就使得它的云可以拓展到边缘云的这个概念这是 KubeEdge 它这个在做的事情。然后它对应的也在那个 CNCF 社区当时是第一个那个边缘计算的边缘云的这个开源的项目。然后后面阿里和腾讯也推出了他们类似的那个项目，但是大家可以看到，就从那个起步到那个当前的一个 star 数，其实目前 KubeEdge 还是属于一个相对来说比较领先的状态，大概占了整个市场40%的份额。然后呢，像24年的时候，我们这个整个就经历了在 CNCF 里面的就原生计算基金会 Linux Foundation 下面从那个沙盒到孵化级，然后到毕业级，然后现在已经是毕业了，所以说它整个的影响力和状态跟那个 K8S 是比较相似的。目前 KubeEdge 在全球呢大概有超过1800个那个贡献者和贡献120个贡献组织，然后我们也下非常多的仓库，整个 KubeEdge 社区所有的仓库大概有8200个 stars 和2300多个 forks，数据是这么个状态。然后里面像是 Sedna 是已经有500个 stars，然后有超过600个就厂商，包括像中国电信等等然后协云等等，都在基于我们的那项目在使用，都有很多的那个厂商高校和开发者在关注。然后呢，我们做过的项目包括一些就是云原生的一些高速公路的项目，在上面我们在高速公路上是有那个收费站的，然后在那边那个摄像头现在用的都是那个 KubeEdge 的摄像头然后我们是那个当时中国这边交通运输这个部门的那个国家重点项目，然后当时管理着全国大概10万个边缘节点，然后上面布的 AI 应用大概有50万个，所以当时这个取消审计是整个大的项目是业界的最大规模。然后呢，刚刚罗纳也提到了，还有一个比较尖刀的项目，就是跟北邮那边天算星座在合作的那个云原生的星地协同的卫星，就把那个 KubeEdge 送到宇宙去。那个卫星反正2、3年前已经发射了，然后上面运行的也是 KubeEdge 的那个，就卫星是端，然后它地面的控制中心是云，这样子的云边协同，我们就在那个叫星地协同星地协同的这样子的一个架构。后面我们还有那个最近跟一汽等等在做那个车云协同的汽车，然后还有一些叫语言生的油田，对吧？然后我们把这些经验总结起来，然后就发布了这个分布式 AI 的显光架云边协同的 Sedna， 这个是比较偏云服务的。然后呢，后来因为发现很多开发者他是那种 AI 的开发者，他其实对这些系统就 K8S 那个 Docker然后 Go 语言这些不是特别熟悉，然后他们可能更像是那些 Python 的这种 AI 的那个算法开发者，所以我们出来了 Janus，然后就把那个当时 Sedna 的里面的算法模块单独抽出来，然后也用来做那个本身高精尖算法的孵化和评估评测那这是那个 Janus project。然后后面当然我们的其他的那些兴趣小组 networking 兴趣组，刚才那个 Ronak 可能也提到像 Edge Mesh Service Mesh 对吧？有这些可以在跨边云去做一些协作但这可能就不是我们这个SIG AI 的范围。然后后面我们也会继续跟大家一起去做更多的那个 像刚才提到的一些具身智能啊等等一些有趣的项目。然后 FS 本身这个我们也介绍一下，就刚才提到那个，反正19年开始我们开始在做，然后它本身其实严格来讲有点像一个线上的那种带薪实习这样。然后呢，嗯嗯，就我们这一次大概会从6月9号开始，然后为期3个月。我们有可能做对这些比较有名的国际的开源项目里面去做贡献，然后有社区的认可，之后还有报酬可拿，那个大约是$3000左右，还是比较好的一个报酬。那今年Term 2的这个 project 我们收到了那个大概46个申请，然后在选拔的时候就有27个学生，然后完成了30项的那个预测试，然后参与预测试的学生占总数大概58%，所以只要参加了预测试，其实已经在比较头部了。然后呢，最后当然我们选了凯威的，然后那整个申请的接受率大概是2.17%，然后那这个最终top one 通过率是3.7%，所以其实是啊、一将功成万骨枯，对吧？所以凯威还是珍惜这个机会，对吧？就有很多那个我们很多学员其实候选人都其实挺可惜的啊，就最后没有被选上，就但我们这个机会其实还是比较难的。然后大概是这么个，然后里面时间是有右边这个表列开的，对吧？刚才提到6月9号，其实我们可以开始了。然后呢，我们中间有2个大的时间节点，可能要留意一下。一个是那个中期考核，中期考核是7月15号，也就是说在那之前，那个我们要完成那个中期考核必要的准备。然后中期考核做什么事情呢？其实也跟现在其他没有参与 FS 的那个学生其实是一样的，就是都是先做那个 proposal 就我们是比较就是跟企业里面是一样的，就是会先做那个项目分析，然后分析完成所有的那个技术设计和架构设计的实现之后，然后我们大家都没有其他疑问了，我们才开始写代码。所以不是上来就跟学校里面吭哧吭哧突然就开始写代码了，就可能不是这样，因为我们这个项目影响的范围可能非常大，干得不好可能对很多对基于 AI 在搞研究的学生、研究团队，然后对一些企业正在用我们这个开源项目的，可能都会有那个重大的损失，所以我们一切的设计都要比较小心一些，尤其对一些比较重要的那个一些 feature。所以我们会有个 proposal， 那 proposal 怎么写，待会会再提到。所以不管是 FS 的学生，还是说新来的其他的成员，如果想要做一些事情，对吧？我们都会让他们先提那个 proposal。然后呢，我们中期考核的那个目标就是这个 proposal 被我们社区的那个 reviewer 们都认可，然后合到那个社区里面的代码仓库里面去。那我们认为这个中期考核是通过的。所以我们现在大概还有差不多1个月左右的时间，然后要完成这个 proposal，就不只是提交，它要合入，就这意味着要获取大家的认可，就这是那个第一步啊，就也是我们第一个中期考核。然后那个最终的考核，就除了那个合入那个 proposal 的 pull request 之外，我们会要求合入那个代码的就实现的 pull request 那这个 deadline 是在那个8月26号。然后它这两个的那个评估会对应它2次的那个呃就奖金的发放就只有通过了这个评审才有奖金，所以这一个是这2个 deadline 是一定要特别留意的。就我的建议是尽快交然后我们可以多做几轮讨论，然后最后使得社区尽可能去认可我们的这些工作就这是这2个重要的那时间节点。然后项目就大家都很清楚了，就我们这个其实是那个Janus 这边，因为现在有超过30个 example 了，然后我们很多有些是已经过时的一些library，就可能3、4年前提的，然后现在用的那个仓库，别的社区可能这些算子什么都换掉了，然后有些项目有可能跑不起来，所以我们会重新审视一下这些 example，然后去做对应的一些更新， 然后一个是要修复一些bug，然后第二是那个完善当时对应的一些文档最后如果有余力的话那看看能不能把我们那个集成测试的那个CI/CD 的整个 pipeline 给它再完善起来，尤其对于那个不同的那个 Python version 的有这个是当然这是挑战项目然后只要做到前面2个，其实基本上是就一个合格的状态，这是这个项目本身。然后这也是LS 那边一个要求的，就是就我们大家对于我们这些做贡献的学员的期望是什么呢？那一个是要去满足我们的那个 code of conduct，就我们平时的一些规范要在社区里面怎么样去工作，这个是要支持的。就不只是说工作方面，可能对于怎么跟大家沟通，对吧？然后怎么样去处理不同的那个代码之间的一些冲突然后怎么去给大家做那个交流和评论，对吧？然后这些其实都是有要求的，就看社区里面是有这样子的一些东西。然后呢，我把这个链接贴到那个chatbox 里面，然后回头那个各位可以再了解一下。然后呢，另外 FS 其实是一个全职的一个 program，虽然我们是线上学习然后但还是要求大家其实大概有每周要投入32到40个小时这样子的一个工作，所以其实是个 full time 的一个 program。另外是大家一起建立一个比较良好的一个交互的一个机制，对吧？然后包括我们这设施例会及我们平时的这些邮件等等那个交流，对吧？然后尽可能大家都顺畅一些，一起做好这个互相的一个交流的工作。当然那个还有一些其他的，比方说我来参加那个社区的会议然后跟大家一起去做在 GitHub 上面去做讨论然后当然做好自己本职的项目里面的工作，对吧？这也是我们比较建议的一些实操。然后另外是刚才提到好像交流的时候，尽可能的尤其是对我们那个项目的一些reviewer就如果有一些要求我们都要尽可能的去不是说所有的都要那个要完全按照那个来做，对吧？但我们可能都要有响应，就是我们认为是应该这样做，我们认为不应该这样做，但是都尽可能的有一个回应，这个是有必要的。然后呢，但另外是很重要的，就是之前也有一些项目的学员，然后错过了一些 deadline，这个东西是个 hard deadline，就是一旦错过了，可能就是我们的一些 evaluation 就没有过所以这个 deadline 是个 hard deadline，我们这些导师其实都会收到那个就要求我们在什么时候提交那个对应的评估，所以这个 hard deadline 是没法商量的所以是一定要特别小心那 deadline，就提前做好准备，然后一定在那之前要确保在那之前一定要过，对吧？这是这个就是这是对我们那个学员大概有这么一些期望。然后第一周我们干嘛呢？第一周一个是我们就像今天一样，然后我们把这个周例会这个机制给它建立起来KubeEdge SIG AI 是每周反正都在就中国这边北京时间的那个4点半每次都是就现在这个时间每周4下午都会开会，然后链接每次都是一样的，我们是有一个固定链接，然后我们就每次就在这上面去讨论对应的项目进展，这是一个。然后第二个事情就是把那个工作环境建起来，然后当然我们通过了预测试，对吧？那个考研这边应该问题也不大，就估计 Janus 的环境是已经打好了，就这么一个，就是我们第一周可以去干的工作。然后CNCF 和 LFS 这边还有一些其他的指导意见，一个是那个一些公共的聊天的渠道，然后这里我们会建议在我们不是这个项目是基于那个ISO 230去做的嘛，然后我们平时如果有一些比较想让大家包括不同的 reviewer 都看见，不同的 member 都看见的话，那就在 GitHub issue 上面去做讨论， 这个是受众最广泛的那个比较正规的那个沟通渠道。然后呢，第二个渠道就是我们现在口头上的，对吧？就是可以去做一些交流，就周例会。然后呢，就按时参与的。另外是，就我们会默认，就是至少在 FS 这个期间，默认那个小薇这边会每一次都上来。那如果有一些什么事情，比方说学校里面有些什么，导致我们可能有一些要往后延或怎么样的话，需要提前跟我说一下。当然我这边也一样，如果我这边有一些什么出差啊冲突了，没办法参加周例会，也会邮件提前跟你说，这么一个习惯，然后大家互相提醒一下，对吧？应该说互相告知一下，就是如果那个有可能会缺席的一个情况。另外对于学员来说，其实一个比较好的一个习惯就是先做research，再问问题，就是就比方说在我们跟各位因为社区的专家其实都很忙然后呢大家要有准备，就是在问问题之前，可能是自己在对于 code base 要比较了解，对吧？然后或者在网上其实是尽量都查找过了，然后在一个比较有准备的一个状态来问问题而不是说就什么事情就都来问一下当然，我觉得基本上能通过预测试的学员都是比较优秀的就应该都有那个自己开展一些 research 的能力就这个只是提醒一下。然后呢，嗯。当然又再次提到 evaluation deadline 的，之前其实不只是我们社区，有其他社区的学员有好几个 miss deadline 的，然后最后就是那个奖金没发下来，所以这个事情他们就反复在提，就这个我们也要传递到就是这个所以我们的建议就是，至少我这边的建议是尽可能早的去交那个 pull request，就刚才提到，反正中期是 proposal 的 pull request，然后那个最后结项的时候是那个实现implementation 的 pull request，然后这两个 pull request 都是尽量早的提出来，就这样的话，大家有更多的时间去做一些修改的动作。然后接下来马上就到中期的1个月之后就是中期的评估，对吧？在那之前我们的 proposal 要 ready，然后呢proposal pull request 长成什么样子呢？反正有一些例子是之前给凯威也发过然后呢然后可能有其他成员对吧？我也贴一些那个给大家那个参考一下。就包括那个 Janus 和 Sedana 其实都有对应的 proposal，然后呢模板是一致的，就是我们每次都是有一些例行的关注的点，一个是那个背景就是说我大概是这个项目是要做哪一些需求我们对需求去做一些分析，然后第二个是说我们的目标就是说我们给这个社区到时候我这个东西如果被接纳了，对吧？我计划是给社区提供哪一些特性或者能力，然后第三是那个proposal 的简要介绍，就它主要是就说我这个东西的范围是什么，我项目范围是什么，我大概哪些是在我范围内的，哪些不在我范围内，对，基于那个我们的目标有一个更具体的一个展开。然后呢，另外是我们的用户是谁，就这个 proposal 到时候做完预计给谁用，是给开发者用，还是给那个最终的那应用的客户在用，还是说是给一些算法研究者在用等等等等吧。然后我们对于不同的 user 对不同的用户的话，他们可能考虑的或需要我们哪些特性可能都不一样，对吧？所以也会要求在 proposal 这个部分去考虑一下我们谁会用我们这个东西。接下来就是重点要评审的东西，就是我们的那个设计的细节，就我们包括刚刚就是大家也看到那个Penia 的那个我们其实重点的讨论都是说到底这个嗯跟其他的方法对吧？我们里面有哪些必要的模块需要去做的，然后呢我们的架构是怎么样子的，我们是用什么样的方法。然后是不是有多种不同的方法去做这个事情，然后我们是要选择哪些方法，然后为什么选这个的， 然后我们到底给社区加了什么东西，然后这个东西对其他人有没有影响，就这些分析其实都是有必要的。这个可以在我们提供的那些就过往那些学员已经写过的那些例子里面去看一下，它都大差不差，大家都是会对这些地方进行分析。然后到时候在会上我们的reviewer也会帮大家，然后一起去看，然后看说还有一些什么东西我们没有考虑到的，然后查缺补漏啊，最后把这整个设计给它做好，然后达到一个基本可用的一个水平那当然还有个 roadmap 的，嗯有对应我们的计划是吧？每个阶段我们接下来这聊了3个月然后每个月分一个阶段，那每个月大概做什么事情，然后这每个阶段里面又有哪一些任务要做，然后去根据前面的这个细节的这个设计，然后我们可以去对后面的整个项目去进行管理，因为这些项目往往都比较大，然后呢，所以我们确实要考虑好，就是这3个月什么东西是做得出来的，然后什么东西是做不到的。然后反过来其实也会影响我们前面的就项目的范围和我们面向的用户的可能会不一样，这么一个整体其实也不是很简单的工作，所以 proposal 这个事情也要比较重视，这是一般 proposal 的写法。然后对于我们这个项目而言的话，就到时候尤其我们有很多要修复的 example， 对吧？我们大概打算修复哪几个 example， 然后它里面有什么 bug， 然后为了修这些 bug， 大概会影响到只是影响这个 example 本身呢，还是说我不得不去修我们 Janus 的一些核心组件，那些核心组件可能不止一个 example 在用，一些共享的一些组件，然后那些可能会影响所有的 example， 然后我们这些其实都要做好分析所以变更分析是非常关键的，在我们整个贯穿我们整个goals proposal 还有 detail design 这些里面在这个过程我们反正多做一些讨论，这是 proposal。当然有一些比较可以去阅读的一些看社区的基本的情况，以及我们一般怎么样去运作的。然后呢，这里当然有一些里面内容很多，我就不展开，我放到两边框了然后大家可以自己去看。然后呢，里面包括了一些就 FS 本身像对于 mentee 和 mentor 的指引，然后呢我们整个 community 怎么样去接触，以及怎么样去做贡献以及我们在贡献过程要注意哪些内容，以及怎么写代码。因为工业级别的代码，其实它有一些，比方说编程规范，对吧？这种东西其实是要大家一起去遵守的然后另外是我们在做GitHub 提交的时候提交的信息那是怎么样去写好一个提交信息，让其他人在看的时候或者说整个项目所有的commit 信息堆在一起，然后形成release node 的时候不会出大问题怎么写好这个提交信息这些有一些基本的操作我都可以在里面自己去做一些阅读。然后举一个例子就是有一个是基本上所有新学员基本有80%以上都会犯的一个问题，就是在交我们的 pull request 时候忘记做签名，就是他可能会需要commit 干 B 然后会后面要加一个一个特殊的指令，然后把自己的签名带上，应该是-S 吧，我记得是 sign 的，然后 commit -S 之类的，然后要记得把自己的签名带上。如果没有加上自己的签名的话，这个在做合入检查的时候是一定会失败的。即便我们所有 reviewer 都同意，也合不进去所以这个签名是要留意一下这个在里面对应的一些指引里面都有这是这个另外是我们社区是有些角色的，大概目前有这么4个级别，一个是我们社区的成员，然后呢也不是谁都可以加，就一般是对社区有贡献之后才会接纳作为我们的核心成员，然后这个是可以去申请的。一般来说，我们完成了一个项目之后 他会考核，就对于那个成员的考核，一般是对于我们曾经提交过的一些 issue 提交过的 pull request 的数目，然后对我们曾经在这些 issue 和pull request 下面的一些评论，这些都会算在贡献里面，到时候都需要举证的啊。然后通过了之后就可以成为核心成员，然后核心成员是下面在社区里面去担任更高职位的一个基础然后呢当我们在里面作为核心成员之后，然后通常是说我们作为导师，然后去带过超过2个项目以上的然后已经有指导能力的，然后对于我们整个社区的那个工作其实是比较清楚的那会升级成为 reviewer，那他 reviewer 呢就可以给一个指令，就是 LGTM 就 look good to me， 有这么个指令的可以去给出来，然后凑够2个 LGTM 的那个 pull request 才可以被合入，所以他其实已经有就 reviewer 就已经有那个打分的一个权利了，这个东西通不通过就是由 reviewer 来做指引，然后另外是那个 approver 的那个权利是这个 pull request 到底最终合不合入，就一般 approver 是看那个有 reviewer 的意见，就如果 reviewer 们都没有意见，对吧？然后我们一般一个项目凑够2个 reviewer， 那 approver 就可以做合入，然后他是最后的把关员，然后他可以用干 approve 的这个指令，然后有这个指令就可以真正把代码合到我们的核心仓库里面来了就这是 approver 这个，然后 approver一般比方说我们带的学生他自己升到了 reviewer 的话，然后我们就会推荐这位 reviewer 可能会成为对应项目的 approver， 就这么一个这么一个升级的机制。另外是 maintainer 那他其实要管的是整个项目本身的所有特性，然后目前的状态，所以他要对全局有了解，而且要做那个一般来说一些比较重要的年度规划，还有那个一些对应的一些商业合作等等这一些的那个工作。然后这块的话一般有2个渠道，一种是说升上来，但是这个例子可能比较少。假如有可能你带的学生变成了 approver 的话，那有可能会升到 maintainer 但这个比较少见。然后另外一种常见的成为 maintainer 的是说我自己在开源社区里面创建了一个新的仓库，就比方说我现在是 Janus 的 maintainer 的原因是因为 Janus 这个仓库其实是我建的，然后我去主社区那边汇报说需要有这么一个开源项目，然后社区通过了之后，说服了所有的那个 TFC 的成员之后 ，TPC 的成员之后那真的开了这个仓库之后，就有可能直接被任命为 maintainer 这是另外一种渠道那 maintainer 管的就是所有的那个这些特性的工作，以及这些人员们任命的等等的工作，对吧？然后当然还有一些管理路线，对吧？然后他对那个这些职责上面是有一定的对应关系的。然后未来可以有兴趣我们可以再详聊的。那整体的社区的结构其实是由这些组成。然后我们现在 Janus 的 reviewer 有2位，就一个是我们线上的石金老师然后呢另外一个就反正我兼任着，就maintainer 也有办法给 review 的命令就这么一个。所以呢因为一个 pull request 至少是有2个 LGTM 的 label， 这意味着就我和石金老师都必须同意这个 pull request 才有办法合入所以所以大家至少要争取我们2位的那个同意才行就提交的东西就这个大家保持沟通，反正我们尽量都会在会上对吧，听大家的那个一些idea， 然后给出一些意见大概是这么一个情况。然后 Sedna 的 reviewer 就有那个唐明老师当然我也兼任，我们还有一些其他的reviewer， 但他们现在可能有一些其他的包括其他SIG以及主社区有其他工作，你可能不会特别活跃，主要现在在承担核心工作的是我们这几位，这个后面也可能会考虑引进新的那个 reviewer， 那到时再说。那目前的状态是这个样子的。 大概是这么多，然后这样的话，社区的工作应该是基本上介绍完，然后先问问那个，就像凯威这边，呃，有没有什么疑问啊？就是对我们社区或者我们后面的这个工作开展。
想问一下，就是说，就是我们到期中之前，就是
嗯，
就是边修 example，顺便去提出我们要去改进的项目的 proposal，对吧？
对，对的，对的，我就
啊，
我们不是 deadline 前提出啊，是 deadline 前要合作。
哦，了解了解，就是这段时
对。
间进行准备这样子。对，
对对，所以我的建议就是你最好这周或者下周就提，就可以把 proposal 交上来了，然后我们开始讨论了，然后讨论个1个月左右，对吧？然后基本上把所有的可能有问题的点基本上都被我们就讨论过，都有解决方案了，对吧？然后到时候合作就会比较有把握
好，我会应该是会在这2天把它赶出来这样子。
啊。然后
对，
到时候我们下周就可以开始那个具体的讨论了，这是
对，
比较好的啊。然后接下来就要不凯威给我们稍微介绍一下，就是当前的一些项目的情况，然后包括我们之前预测试的一个进展，对吧？然后啊、以及后面可能打算往哪个方向去努力。
好的。那我看这边是我的小小的报告。对，好。就是这报告会主要是分成2个部分，一个会是我的 pre-test 的 report，然后另外一个
嗯哼，
是我的 future work。我 future work 目前是想说建立一套就是 example 的验证 CI 的 framework。对，好，首先是诶呀，首先是关于 pretest 的 report 的部分。就是为什么会选那个 LM 的 sample QA 这一个 example 呢？就是首先就是主要原因会有3个，一个是因为它是 LM 相关的 example，因为大家也知道，就是 LM 最近非常的火热。对，那而且跟那个我们专案的那个 AI benchmark 的发展的方向有高度的相关性，所以这是第一个原因。然后第二个原因是因为它相对的简单，就是很容易作为就是刚看到这个 repository 的那个贡献者进入这个专案第一个看到的 example。对，然后第三个就是它理论上就是应该是可以在我们干净的环境中直接的运行。对，所以这对 example 的可重现性非常的关键，这样子。然后我的 pretest 的目标就是在 project 中执行一个简单的 LM 的 question answering 的 benchmark。那整个流程是从 config 的读取，然后接下来是 dataset 的读取，然后再来是 model 的那个预测，对，然后再来是 interface 的部分，然后再来是最后是评估，最后是产生 result 的部分。然后这次的 pretest 目标其实就不只有修这个 bug，就想说是去探索说为什么这一个 example 没办法顺利的进行这样子。然后就是我主要做了3件事情，就是第一件事情就是调查现在有哪些问题，就是哪些问题会去阻挡说就是一个新进来的那个合作者会是说就是会遇到的，看到这个 document 执行后会遇到的所谓的就是会遇到的 bug 这样子。然后再一次确认说过去相关的issue或 PR 中有没有提到相关的问题，然后再检查现在的实际的状态。那最后交付的一份就是那个 root cause 的分析这样子，然后以及去提交后续的修复计划。那首先关于就是相关的 issue 的部分，我们把 issue 分成有4个类别。第一个类别会是 core execution 的 blockers，也就是造成 example 没办法执行的主要原因。这里包含就是 YAML 的路径错误，readme 的那个指令的过时，然后使用本机的模型路径，然后缺少 preprocess 的步骤，以及缺少那个 dependencies。对，然后这些问题就是使用者及时按照文件的操作，没办法成功的跑起 benchmark，所以这类的问题应该会是就是我们修复该优先处理的项目。 然后第二类的问题会是 dataset 跟 documentation 的 reproducibility 的问题。然后这里的问题包含缺少可以重现的 dataset 以及 dataset 的说明不清楚。对 example 来说，就是这个文件跟资料集如果没办法重现的话，就很难作为稳定的 benchmark 的范例这样子。然后第三类的问题会是 runtime 的 evaluation 的 edge case。对，然后我发现就是有些那个 example，就是说假定说使用者一定会有 CUDA 的环境，那实际上说就是因为这 example 其实它的用了一个比较小的模型的 LM 模型进行，所以其实可以在 CPU 或是在 Apple Silicon 上面的 MPS 上进行。所以说，如果说这 example 如果没有相容这两个环境的话，就会降低它的可用性。然后另外就是 evaluation 的部分，也有一个 edge case，就是就是在那个除数就是 prediction 是空的时候，那就是运算的部分可能会遇到除以零的 error。对，虽然就是这些问题可能不会造成就是使用者的困扰，但是会让 example 会在特定的情况下会遇到困难的。对。然后最后我还去参考那个 dataset 的 format 的历史问题，就是137的这个部分，可以看到可以让我更了解说，就是为什么就是这个 dataset 会长这个 example 的 dataset 会长这样子。然后最后是关于 PR 的分析，就是最后看完就是 PR 之后，我认为说就是这个388是最最适合作为那个 LM Simple QA 这个修复的 baseline 的 PR，就是因为它是比较针对这个 example 的所有的执行问题，所以想说是可以作为主要的基础。然后 PR384是可以作为补充的项目，因为它处理的是那个就是出于零的那个 error 的问题的 edge case 问题，所以想说它可以作为补充。最后就是这个 PR241可以作为就是那个 documentation 的 set up 的改善的参考这样子。然后就是其他几个 PR，就像是429，虽然它比较新，但是因为它是对核心的代码进行改动，所以我们可能需要更审慎的评估这样子。然后就是236跟328，虽然就是它提供了早期标准化的 example 的修复流程的参考，但是它可能，我记得忘记了。就是它虽然提供了比较早期化的 example 的参考，可是个人认为说它可能比较不适合作为我们的 baseline 的 PR 这样子，所以最终的建议是说，就是388作为 baseline，然后就是搭配384的那个除法的运算，跟参考241的改善文件这样子。然后这是关于我的 pretest 的一个短短的 report，然后再来是我的未来工作的 proposal。就是我现在目前是计划说，就是因为目前的透过 pretest 的可以看到说，就是其实因为其他的 example 也有这个问题，就是 project example 并不是单一的，就是单一个 example 会出现这个问题，所以而是整体的维护机制上的事情。所以如果在未来，因为现在专案里已经有30个 example 了，如果未来继续增加的话，其实我们之前的 example 更会收到就是 dependency，然后就是 Python 的版本，然后就是上游 library 的更新的问题，还有就是 runtime 的configuration 的问题，所以以及那个文件过时的问题的影响。所以最在现在的专案来说，就是 example，你要知道它有问题，就是只能靠人工的手动的去测试才会去发现的。所以很长就是实际要执行的时候才会发现说这 example 有这样那样的问题。对，然后新的 pull request 可能会去影响就是我们之前所有的 example，所以会可能让它失效或是让它过时这样子。对，所以我提出的 future work 是建立一个自动化的 CI 的 validation 的 framework，用来持续的检查就是 example 它是不是可以运行的，跟它是不是过时的这样子。然后这个 future work 的核心就是刚刚讲，就是 validation 的，我们对 example 进行 validation。对，所以它包含4个部分。对，第一个部分就是建立一个 example 的 manifest directory，它就也是建立一份就是 example 的清单，记录每个 example 需要的路径、依赖的路径跟它的依赖跟执行方式，以及是否需要 GPU 跟是否需要 dataset 等资讯，就是先把它统整起来。对，然后然后第二个会是就是静态的验证，然后就是这一部分就是会检查它的 YML 的 path 跟 README 的 command 跟那个 hardcode 的 local path 跟 dependency 的问题，就是这一层就会解决上面这几个问题。然后第三层就是 runtime 的那个 smoke test。对，然后这一层就是会去选择一些代表性的 example 执行最小化的测试，确保说他们就是可以正常的启动他们主要的流程这样子。然后最后一个部分就是回归测试的部分，就是当 PR 有可能会破坏说已经修复好的 example 的时候，我们在 PR merge 的时候，CI 可以先发现说这个 PR 可能会有造成某些 example 失效的问题，所以避免说这些会造成 example 失效的问题会神不知鬼不觉的进入这个 main 的 branch。对，那我想说这套框架的好处是更早的发现，就是会有破坏 example 的状况，然后降低新贡献者就是 onboarding 的成本，以及提高 example 的那个可修复性，也让 maintainer 更好的去维护 example 这样子。然后对于未来工作的部分，除了就是持续修复现有的 example 以外，就是我把从现在到期中其实还要分成3个里程碑这样子。第一个部分是6月15，也就是下礼拜开始，推到6月28。这个阶段是会先定义那个修复的 scope，然后会是对于 CI 的 validation 的strategy 进行分析这样子。然后具体来说，就是我会先 review PR，主要是先 review 最近有 merge 的 PR，也就是406到408的部分。对，也去看说现在的专案是往哪个方向啊，然后以及现在目前的 example 的结构这样子，然后会建立就是 example 的清单去整理说哪些 example 是可以执行的，然后哪些是坏掉的。然后在此期间，我也会顺便定义就是 CI 的 check level，就是刚刚说的那4层，就是会去把它更好的去定义这4层的层级。对，然后会去推产出第一版的那个 CI 的，就是会更新我第一版的 CI 的那个 workflow 的 design 这样子。然后第二部分就会是6月29到7月5号这个期间，这个期间的目标其实是建立一个可以运行的 CI，就是可以初次跑起来的 CI 这样子。对，然后就是目前规划是说会这个 CI 会自动检查几个项目，也就是刚刚第二层的项目，也就是会测 YML 的 path，然后 hardcode 的 local path 跟 dependency 之类的问题。对，然后也会对几个具有代表性的 example 做 smoking test。对，然后就测试说 CI 在不同的 Python version 下它的行为这样子。然后最后一个部分就是期中前的最后一个部分，然后它的时间会是7月6号到7月21号。这个期间，这主要是要准备，就是准备根据 就是这个 maintain 这个 CI 的会给那个我们的 mentor，然后他会根据他的 feedback 去调整，就是就是我们 CI 的 pipeline。对，然后同时我就是会去建说它的 documentation，就是这个 CI 的 documentation 跟 debug 的 playbook，去帮助使用者，就是帮助新的贡献者说，就是为什么这个 CI 会失败，然后这个 CI 失败的时候会怎么修复这样子，然后会准备就是最初始的 PR，就是会导入就是就是刚刚讲的，就是这个 pipeline 的部分。然后会整理现在的 会目前就整理的到时候修复好的 example，以及原来存在的那个会有问题的 example 这样子，对吧？对，然后在这个期间，当然就是确保我们的那个 proposal 就是会一定要是完成的，对，然后就跟刚刚讲的，就是我们的 CI 的 validation 会有一个雏形这样子，对，好，我的报告就是到这样子。然后如果各位有什么问题的话，可以提出来，或是说我哪里做的不好的地方，这样子。
我们讨论一下。然后凯
好，
威整个在预测试的时候其实表现是非常好的。然后呢，在整体的我们两个测试任务对吧？一个是前面的那个对现有 issue 的分析，以及现有 pull request 的关系上面然后都把整体的我们每一个 issue 以及它出现的情况做了分类这个是特别好的啊。另外一个是对于我们这些 pull request 里面的分析，可能是有跑过对应的命令的执行，对吧？其实对于它整个的那个 pull request 的理解是比较深的就每一个 pull request 的关系以及它的好坏优缺点，我们怎么以什么顺序合，对吧？这些都有考虑，这是那个凯威被选上的一个原因，我们认为是有能力去完成我们这一次的这个项目的。是非常好的一个表现就是在 pre-test 里面，这里还是要非常感谢那个凯威对整个那个预测试阶段的那个投入就非常好。然后呢对于我们接下来要干的事情，对吧？我们可能有几个点，一个是那个对于 CI 这一个是非常好的就我们其实非常希望看到有学员愿意去挑战一下 CI 这个事情。之前那个 Abhishek 也尝试去做但那个可能我们的 example 量还是太大了，然后可能没来得及完成那个 CI 的任务，然后后来你现又也是想做尝试，然后最后也没有来得及做完那个 CI 的工作。他还是有提到一个 CI 的，好像有提到一个 CI 的 break， 但其实没有解决最终问题。然后主要 CI 这个确实是有难度的，就我们到时候可能对整个 CI 的使用的工作流有几个方面要去考虑，一个是谁来用，对吧？然后 CI 是不是一般来讲可能有两方面的使用者，一个是那个像 maintainer，他要去对每一个尤其是新来的一些 contributor 在交那个 pull request 时候，他会触发那个 CI，然后这个触发动作其实是尤其是第一次的那个 contributor 的话是要由 maintainer 来触发的。然后呢，接下来触发完他怎么样去测？到时候是我们对每个代码都去跑一下所有的 example 呢，还是说不是这样子的？他跑某几个比较典型的 example 作为是否能通过的测试。这个其实是要考虑的，就我们这个 CI 怎么去用。然后最后是说，因为这个东西测完，有一个非常重要的用户就是开发者，对吧？他来提交这个 pull request，那其实最后是他要去改。如果发现了 CI 里面有问题，对吧？可能不是 maintainer 来改，是 CI 就是pull request 的开发者，他要能够看到这个 CI 的 feedback。那么我们基于这两种用户，对吧？他们可能想要看到的东西不同，所以 CI 这一个我的建议是什么呢？可能需要画一个那个用户的一个用例，就是说对于 maintainer 他怎么用我们这个 CI framework，然后对于开发者他又怎么样用我们这个 CI framework，他预期他先做什么动作，再做什么动作，最后得到什么 feedback，对吧？我们把这一个给他在 proposal 里面写清楚，就呃我的期望是，应该开发者也要能够看到 CI 的 feedback，这应该是做得到的。我记得是会产生那个 CI，即便测完它也会产生一些报告出来的，就我们可以在里面去做一个体现。然后设计的难点，我觉得就是刚刚我们提到的，怎么样算通过呢？就是这个 CI，我们到时候是准备建一个，对所有 example，比方30个 example，是不是每个人提交代码之后，这30个 example 都得跑一遍才算过？还是说不是这样子的？他只要他提交哪个 example 的代码，他就测哪个 example， 还是怎么弄？然后我怎么保障这个流程是跑得起来的，对吧？其实这里是有点挑战的。当时 Abhishek 在做这个事情的时候，他是考虑就是先放几个典型的 example，比方说2、3个 example，尤其是我们确保已经是过了的，就是现在跑起来是没什么问题的，然后用来做这个 example 的测试。但里面其实有很多东西要考虑，对吧？我明明是我这个开发者是提交了 A example 的代码的，然后他让我去测 B example，然后测完然后过了，即便过了，它能够说明我 A example 没有问题吗？然后，但如果测全部的，对吧？那也会有类似的考虑。就虽然我 A example 提交的时候，然后我去测 A example 确实通过了，对吧？然后呢，但是 C example 出了问题，那能说明是我 A example 提交的时候的问题吗？其实这里是这个 CIA 其实讲起来确实是一个它的用户的这个用力，使用的用力，它使用的整个流程其实这个逻辑其实这个用户的使用逻辑其实还是要考虑一下的，并不那么简单。所以这是我第一个建议，这个东西可能要引起重视，就是我们打算让哪几个用户去用。然后哪几个类型的用户去用，然后他们分别在这个过程中会看到什么东西，然后他怎么样用起来的。然后我建议你举一个例子，对吧？比方说，就跟我刚才说的，我是 A example 的开发者，然后我交了一个 A 的 pull request，然后以这个为例，然后那他怎么走完整个 CI 过程，然后怎么样算过，怎么样算不过，对吧？然后呃我们先画这么一个流程出来之后，然后到时候这个整个 CI framework 怎么设计，可能就会慢慢的有哪些关键模块，可能就会更加清晰啊。这是第一个建议，就整个 CI 的用户流程，它的在工业上，在公司里面会叫用例，对吧？这个用例需要这个用例视图要先出来，这是第一个。第二个就是当时也是卡住 Amazon 的另外一个点，就是这个 CI 跟我们的那个Janus 的仓库是个什么关系？就我理解它可能我理解它可能不是直接合到 Janus 的核心代码里面的，对吧？就是它其实是那个合到它的那个 CI 的那个代码里面去的。那是不是这个东西是不是按理来说，那是不是就是 GitHub 的使用者才有办法去打开？然后这个东西如果我们的用户他的开发者他在本地跑项目的时候，其实他是没办法用到这个 CI 能力的，是不是这样？然后这个我们可能要明确一下，就是 CI 跟 Janus 的关系，它是不是日常其实用不到，它必须在做 GitHub 提交的时候去做使用。然后呢，怎么得到的这个反馈，对吧？就是 CI 这个framework 跟我们项目的关系，我理解应该是跟 GitHub 去抢板定的，它其实是交到那个呃我们的一些 GitHub 的测试代码里面去，它不是交到那个 Janus 的仓库的，所以但它会不会因为它其实跟我们 Janus 的仓库其实有交互的，比方说我为了过这个 CI 的测试，然后它必须去读那个 Janus 里面的一些现有的 example 的代码去跑通，对吧？所以他们其实虽然这个 CI 的代码并不会合到 Janus 本身，但是呢，它跟 Janus 本身的一些 example 是有交互关系的，跟哪些模块有交互关系？然后会不会导致我需要去改或者去调整 Janus 本身的核心代码？这个分析是不管我们结论是有还是没有，对吧？要不要改，对吧？需要给出一个明确结论。这是我们 proposal 里面我觉得第二个可能要考虑的点，就是架构分析，就是我们到时候写出来的代码是改这个仓库的哪个模块哪个部分，然后跟这些现有模块是个什么关系，然后预期哪些人会受到影响，我们是否要去降低它的影响的，就是架构分析的时候只是要去做的事情。所以我觉得可能我们下一次可能就开始进入到设计的就是细节这里来了，可能就是第一次讨论用户怎么用，对吧？就有哪些用户他怎么样跑完整个用户历程，然后第二是我要为了实现这个用户的用力，然后我这些代码跟我现有的我打算往仓库里面提哪些代码，然后跟我仓库里面的这些模块是 什么关系就这个可能是我们下一次我们希望看到的。
了解，记录一下。
对，看看有没有疑问啊？就是这其实还挺难的，就是不是那种说我拍一个脑袋5秒钟能得出结论的，就它其实稍微需要设计一下。就是一般来说，这种活都是在公司里面是由产品经理和那个架构师一起去做的。当然，我们这个项目相对简单，就它没有那种贼复杂的那种云服务组件和现有组件的血型分析，所以它相对纯净一些啊，其实比较适合我们那个开发者来单枪匹马去尝试去挑战一下。但这个事情确实它也是就刚才我讲的这2个方面，可能呃呃以前很多学员会不理解说为什么我们还要在不立刻写代码，还要搞这么多那个 proposal，其实就是这个原因。就其实这2个东西在工业界都是有专门的角色的，有专门的人去看护的，都是对这个项目有重大影响。就这个项目最后成功与不成功，对吧？其实这2个就看这前面这部分做的多好。如果考虑的足够仔细的话，其实后面会少写很多代码，当然后面可能会来回返工。或者说最后弄完没有人要用，就我们要避免这个项目有重大失败的这个情况，所以这两个事情都是其实可能要做重视的。我补充一下。
想问一下，就是我们这个会议，就是后续会收到他的录影吗？对，因为有些
会
东西可能
对，因为确实对，应该考虑的东西比较多，对吧？然后
对
我给大家发一下那个，其实我们在 B 站上面是有那个呃有有账号的，呃我发了一个在吹播时间发了一个，大家看能不能打开。
能可以。
对，就我们每周的这个录屏呢，都会往上面去放啊，然后呃当然它可能不会特别及时啊，就是我们社区运营，它可能要晚个1周2周是有这个可能性的啊，对，所以所以可能也要就后面可以再反复再多看一下，对吧？然后呢，反正我要说的就2个点，就可能现在就可以，反正一个是那个用户用例，对吧？然后第二就是那个架构分析。这2个其实是我觉得接下来我们这个 proposal 可能要重点去思考的。就就是这个，啊，然后有什么如果刚才我讲的这块有哪里那个可能需要我再强调一下，或者说怎么样展开一下，也可以让我知道，对吧？然后啊，我们现在就尽可能让你大概有个感觉，说我们大概要做个什么东西出来。
有我对这个部分，其实因为这学期刚好有在修这节课，所以
嗯。
非常的印象深刻。
那太好了。你们应该是学校有教那个我不知道软件工程或者架构设计的课有没有？如果有的话，其实
哦，
其实是挺实用的。
有都有
那
修的。
那太好了，你可以把那些书翻出来，这些是真的有用的啊，就那个呃，就用户的用例视图，对吧？然后呢那个架构设计，对吧？不过架构设计，反正我没有看到学校的课有特别好的，但总之我们其实想，所谓架构就是我们软件和软件模块和在哪里及它们软件这模块之间的交互关系的这个事情。然后到时候我们这个 CI 对吧？它大概会要写哪几个模块，然后这些模块跟现有的 YAML 的代码是怎么交互的？就这个交互视图对吧？就这个是反正就2个，相当于你就聚焦2个图，一个是那个用例视图，就呃，然后另外是那个架构视图，就这两
好的，
去
了解。
对去画，把这2个图画出来，然后把对应的字写出来，对吧？然后写的这个过程，如果发现写不太出来，对吧？就可以就可能需要进一步的去做一个研究。然后
好，
注意2个角色就是了，注意2个角色就是那个可能会用这个 CI 的人，有一个是 那个开发者，尤其是开发者。然后第二是那个 maintainer，这两个角色他都期望我们期望给他看到什么东西，然后他到底怎么用我们这个代码，就这个。我们下周可能先把我的聚焦用户的先讨论清楚了，那看看有没有什么问题。然后你一边可以开始想那个就是架构这边怎么是个什么关系，我们打算给社区贡献什么代码，就这个，OK，
好的，了解。
再看看有没有什么我们需要讨论。
目前我这边目前还没有问题，可能要研究下去才会发现
对，
问题吧。
可能对，你也可以自己试一下。对我另一个建议就是，之前不是预测试的时候你有在做那 LLM 的嘛，然后你可以以那个为例，对吧？然后比方说你打算就是凯威打算自己作为用户，对吧？你要提交一个那个 LLM 的这个修复的这个代码，对吧？给到社区，那按理我们这个 CI 出来，这是个什么流程，对吧？都分别需要经过那 CI 会去帮我们做哪些事情，对吧？你可以以自己的这个实际的例子为例，然后一边教这个 CI 的这个呃 proposal 的同时，然后一边尝试以一个你比较熟悉的一个 example 为例，对吧？然后一边修复这个 example 的同时，然后一边尝试构建这个 CI 过程，就可能这样的话会具体一点，就比较好写这个用例。
好的，嗯，
然后大概是这样，就是在你本地，其实那个大模型那个 LLMQA 那一个 example 跑得通吗？
跑得通，就是我修完好了。
已经修好了的，好，那行那行，
对，
然后你就以那你就可以以那个为例，然后去那个呃去做 CI 的设计，然后当然那个 LLM 的那个修复本身也会作为你的贡献，对吧？所以你的 proposal 里面可以有两个部分，一个是那个就现有的一个 example 的修复第二是这个 CI framework，就这两个你都可以加进来啊，就这样的话，我觉得其实都会算到 LFS 的成果里面来的。
好的，
行啊，时间也不早了，我今天那个因为第一次，所以那个事情可能特别多，就像贼大，对，到时候可以关注一下 B 站的那个他那个回放对吧？然后可以有些有需要可以再消化一下，然后呢有什么问题咱就多联系啊，那个反正我的邮箱你已经有了，然后呃嗯，如果你有微信的话，对吧？然后我们其实 SIG AI 是有微信群的，我们也可以通过微信来做那个比较实时的交流，这种也行。然后或者没有的话也没有关系，就用email 因为我们在公司里面是不能，我们那个电脑是没办法装微信的，然后我们那电脑是强制用邮箱，然后所以你一般给我发邮件，我会比较容易看到，反而我们工作时间反而不怎么看微信，也反正都行啊。然后呢，这是这块啊
那
啊，我
微信
们就用邮箱呢，还是你怎么看？我们平时
想说先以邮箱为主，但是我微信也可以先加一下您这样子。
好，这有我的手机号，我可以用那个手机号去，你搜那手机号，我
哦，
看有没有打错啊？嗯，对，你可以用这个手机号搜到我，然后就可以加一下我的微信啊，然后我们但反正我们优先用那个邮箱，微信我可能平时看不到，我可能得下班之后我才会去读那个去处理那个微信上的消息。
好的，
但有些相当于如果我们有些社区，包括社区其实有一些公众号或什么东西的，然后到时候你也可以在上面看一下，这个 KubeEdge 之前的那个成员们对吧，都做了些什么事情对吧？然后可能对这个社区有更深入的了解。
我发你交友邀请了。好了，
嘞，那个到时候我还没说到
然后我没有他挑了一个验证出来，
啊，那个呃，
我还是
就这
会后加
对没有
他需要
啊
电话
啊，慢慢
验证。
我好像看到了，哦没有了，这是 OK。然后呢，平时其实我们项目其实都反正每周也都会就开这个例会嘛，然后我们就大家一起把这事情再做一些更细致的讨论。嗯，我想想啊，然后看吧，我反正到时候社区公众号反正回头加完之后我也推你一下，然后大家都可以去看看那个上面有一些工作嘛，都可以一起看一下。然后呢，LF 这个事情是个契机吧，就是使得大家可以认识，就是互相认识，然后一起工作，然后一起这个是很好的。然后呢，后面其实你可以看看，就是我刚才提到，就是我们其实社区其实是有一个晋升机制的，那就是嗯。不是说那个做完项目然后就那啥了，就其实还有很多事情可以一起往前推进，对吧？也可以考虑一下，就是啊、就是啊、因为在简历里面，其实他有时候不只是看看你的项目其实也看你在那个一些技术上面的工作上面，对整个产业有多大的影响力。然后我们看社区其实相当提供给大家这么个机会，就可以参与到一些比较有意义的、比较有意思的一些项目里面来，然后跟去帮助更多的人，然后去做更有意思的事情，然后这些其实可以通过社区来完成。然后可以比较专注于技术上面的一些考虑的，就其实是这个层面上面的，所以其实未必只是说做 LFS 的这么一个项目的，可能可以有以后可以做到更大的事情就这个是当然你可以先从这些合作里面，然后慢慢的了解这个社区本身在干嘛，对吧？然后再看看后面那个就是有机会，然后继续来做更大的事情，就是这块。反正很欢迎大家加入啊。那个其实有很多事情可以一起做，到时候我们逐步讨论的过程，可能会有新的 idea 出来。
好的好的
好嘞，那时间也不早了，哈哈，那要不我们今天就到这，然后大家去吃晚餐吧。
好的，谢谢大家。
好，谢谢大家今天来参会啊。然后反正我们下周还是同一时间在这边开会，然后那个也欢迎大家参与啊。各位，那我们今天就先到这里，各位拜拜。
好的，谢谢大家，谢谢。
谢谢。